All right, welcome back, everybody, to another exciting installment of calculus. What we have here is assignment 1B, which is a review assignment on trigonometry, everybody's favorite topic. And historically, this is one of those things that you don't need to know a whole lot of trigonometry. Trigonometry, if you've forgotten, or pretty much anything that involves sines, cosines, tangents, those sort of things. So it's not that you have to know a lot of trigonometry, but one of the things that will really help you out is really being familiar with the unit circle. That's really the extent of what you kind of need to know when it comes to trig as far as calculus is concerned. So before I get to this page right here, let me just kind of bring people up to speed, or maybe act as a helpful reminder on some of the big time things as far as the unit circle is concerned. Okay, let's just talk about the familiar numbers, the numbers that are often the answers. Okay, and so the numbers that you kind of have to get in mind are the numbers 0, 1/2, square root 2 over 2, square root 3 over 2, and 1. These are the big pipe pounders of trigonometry and the unit circle. And you need to just kind of pretty much commit these various numbers to memory right here. You need to commit these to memory. And what will also help is if you understand the general size. Like if I were to convert these into decimals, these are written now in an increasing fashion. So like again, this would be 0, this would be 0.5, square root 2 over 2, jeepers creepers, it's just getting worse. The square root 2 over 2, 0.7071, square root 3 over 2, 0.8660, and 1. So as I said, these things are in an increasing fashion. Now, how will this serve us? Well, when you look at a unit circle, what it really is just breaking things down into triangles. I'm going to just look at very specifically quadrant 1. Okay, quadrant 1 is this. Now, there are points right here, and then there are 3 really important points in between. So there's the point middle, and then there's this like low angle, and then there's this high angle. Something like that. So think of it this. Now, the reason that they call this thing a unit circle is a unit is singular. It is a unit implying 1. So what this circle is a circle that has a radius of 1. So again, a radius is the distance from the middle to the edge. So if this is in a like a graph, a graph, and you are on this x-axis at the very bottom, and I go out a radius of 1, this would obviously have a coordinate of 1, 0. Okay, the x-coordinate is 1, the y-coordinate is 0. And then if you look at the very top point, the x-coordinate is 0, the y-coordinate is 1. All right. Now, but what about these others? What about these other 3 points? All right. So the one straight up and the one straight out are really easy. But if you think about this, what is the what is the x-coordinate? What is the y-coordinate? Is the true question. Okay, so if I look, and I know it's kind of hard to explain. Oh, okay. If I look at point D, all right, think about what is the x coordinate, what is the y coordinate. Well, you see that the x coordinate of point D is really big. It's really big, not as big as 1, but it's really big. What is the y coordinate? Oh, the y coordinate is really small. So if I take a look at my important numbers, the numbers that show up all the time, which is the one that is really big, but not quite the number 1? Like, what would the x coordinate be? Well, that would be square root 3 over 2. It's the big one. All right, well, we also mentioned that the y coordinate is small. So what's the small number? Oh, that's 1/2. Very well. Now, if you take a look at point B, you notice that the y coordinate of point B is really small, yet the y coordinate is really big. And then point C is, equidistant with the x and the y, so it's the one that is in the middle. The y coordinate and the x coordinate are the same. And so this is kind of a quick, simplistic version of understanding the unit circle. What are the coordinates and where do they go? Now, all you have to do is take these things and remind yourself that this is indeed, a positive x and negative x, a positive y and negative y kind of concept. So these coordinates in quadrant 1 are obviously all positive. Now, but what would the point right here be, for instance? Okay, well, I noticed that the x coordinate is a long x coordinate. I know the y coordinate is rather small. But then you have to realize, oh, this has a negative x and a positive y. So make sure you attach the signs in the proper quadrants when you're filling out this unit circle. All right, so back to the actual unit circle itself. These outside ordered pairs are meant exactly for this purpose. So this has a 1, 0. This is 0, 1 at the top. This first one, this x is really big. The y is really small. Okay, jumping 1, I see that the x is really small and the y is really big. And then the one in the middle is the one in the middle. Again, you have to pretty much memorize the square root of 2 over 2 and the square root of 3 over 2 kind of concept. You have to memorize these numbers. Don't rely on tricks of like, oh, I remember these as square roots over the number 2 or something like that. Like, don't rely on tricks. Like, you just kind of have to know it. That's my best advice to you. All right, so continuing this around the horn here, this is a small x, big y, medium x, medium y. This is a big X, small y, and then notice that these are all negative x's, and this has a negative 1, 0, because this is a circle in the negative x direction. Okay, looking down here at quadrant 3, again, this has a big X, small y, medium X, medium y, small x, small y, excuse me, big Y, excuse me, down really far from the origin. These all have a negative x, and they also have a negative y. One down here has an x coordinate of 0 and a y coordinate of negative 1. And then quadrant 4, starting at the bottom here, small x, big Y, medium, and big X, small y. These all have positive x's and negative y's as such. Okay. Now the rest of these things, what belongs in these other blanks? Okay, the degree symbol is obviously degrees. So usually, we don't usually use degrees all that much anymore. So these are the important things. So the ones on the flanks, let me describe it. This one and this one are 30-degree angles. So you have 30, 60, 90, and then that repeats in 30 degrees going all the way around. And then the one in the middle is your 45s. Okay, is your 45s. So got my 30-degree angle. So my 30-degree angles would be 120 and 150, leaving this to be 180, obviously. And then your 45 would be 135 on that. Okay, your 30-degree angles would be 210 and 240, leaving this to be 270. So that all checks out with a 45 in the middle. And last but not least, continuing our 30-degree concept, 30 degrees, 30 degrees. Leaving this angle right here to be 360 degrees, which is absolutely true. So it's all good. And then a 45-degree in the middle. Ta-da. Okay, last but not least, as far as the unit circle is concerned, is the radians themselves. And so let's go back to our picture here. Here. Okay, looking at our unit circle, what's the most important is understand that pi is your 180 degrees. So a complete circle is 2 pi. So that is your really base information. This is where everything begins. So that is 0. And so that's that. All right, so let's go with the basics. If the whole thing is 1 pi, okay, what is half of that? Well, that would obviously be a half a pi. Okay, let's start with that idea. All right, so if this angle is a half a pi, well, what is half of half? Well, half of half is a fourth, of course. And so that would be your pi over 4s. So these middle angles, the mid angles everywhere, are your fourths. So you have like 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4 going all the way around. All right, so I'll jump back to the unit circle and actually put those into play. So 0 begins here. So this is 1/4. Yeah, I would call it that. 2/4, aka 1/2. 3/4, and 4/4. Continuing the 45s all the way around. 4/4, 5/4, 6/4, 7/4, and 8/4. Okay. Those are those. Okay. Now, I want you to kind of, so this is a pi over 4 kind of concept right here. Now, investigating these other ones, this angle and that angle right there, what are those? And so I want you to consider 2 different numbers, okay, and think of this as an angle. You have the number 1/3 and you have the number 1/6. okay? 1/3 and 1/6. Which one is bigger? Well, obviously the 1/3 is bigger. So if these are angles, and I give you the option, I'm talking about this point or this point, and again, these are angles, what would you guess this upper point to be? What degree in radians would you expect that to be? Well, I would expect it to be the bigger one, of course. And that is exactly what it is. It's 1/3. Okay, where these little guys are little teeny tiny angles, sixths. Sixths are really teeny tiny angles. All right, sixths are really teeny tiny angles. And so if you just kind of think of that, that's what they are. So sixths are really teeny tiny, aka they're really close to your horizontal line. Because it's a really small angle to get to these sixths. All right, so back here. Which one would be your teeny tiny angles? Well, it'd be this one. And jumping all the way across your circle, it'd be this one. Those are the teeny tiny ones. Those are sixths of something. This one is 1/6. Okay? And this one, if you're approaching the number 1, and I'm breaking this down into a sixth, what is just a little bit short of 1? Well, it'd be 5/6, because 6/6 would make it. Okay, jumping down to the tiny angles. Again, they're close to that middle x-axis. So these are sixths, all right? This one at the 210 degrees is just a little bit bigger than 1. So it'd be 7/6. And at the 330, it's just a little bit smaller than 2. Thus, it's 11/6. So the ones that are close to the horizontal are teeny tiny angles. That's a little angle, so it's going to be a sixth of something. Now, all you have to do is just identify, is it bigger than 1? Is it smaller than 1? Is it, approaching 2? Those sort of things. Right? So if this is 6/6, that would mean 5/6, and this would be 7/6. That's what I'm implying. Okay. Then on to the thirds. The thirds are pretty big, and so the thirds dominate all these big angles that are not quite straight up and down. And it's pretty self-explanatory. This is 1, this is 2, 3 would be the pi itself, 3, this would be 4, and this would be 5. There you go, you got your unit circle. Again, the radians are pretty easy to figure out as long as you know the key denominators of sixth, fourth, and thirds. Right? If you kind of know those, you're pretty good. And then again, my advice is to just memorize those key numbers out there. And again, you can ask my previous calculus students. You need to know this stuff. You don't have a cheat sheet to run off of. You can't, like, when you're taking the test, you don't have time to be looking up this crap. Like, you need to know it. I can't emphasize this enough. That's why we're taking a moment and actually doing a worksheet on it. All right, so some of you might be up to speed. Some of you might need to work on it. So again, this is your reference to that. Okay, what else is to this? Okay, some basic trig identities. Like how do you manipulate sines and cosines and things like that? I don't think I need to really be mentioning SOHCAHTOA. It doesn't really come into play all that much, but just know what that is in reference to. Like, so for instance, if you have a 90-degree triangle, and this is the angle in question, all right, and let's say that this is a 3, 4, 5 triangle or something like that. And I want you to set up, hey, what is the sine of the angle? What is the sine of the angle? Oh, the sine is the opposite over the hypotenuse. Okay, that's self-explanatory. That's easy peasy stuff. But again, you should know what SOHCAHTOA is. Okay, as far as the trig is concerned, the only tricky one is this very first one right here, where you have sine squared plus cosine squared. This is one that you kind of need to know. Sine squared plus cosine squared is equal to 1. All right. And what these next three problems are implying is just manipulations of that well, not those next three. The next two questions are just manipulations of this. So for instance, if you're solving for cosine, cosine squared, what would you do? I would subtract the sine squared. And so that would leave cosine squared to be equal to 1 minus sine squared. And so that would be that situation right there. And then same with the sine squared. I would just subtract the cosine squared. So 1 minus cosine squared. That. Tangent, what this question is asking you for is what is this in terms of sines and cosines? And a tangent is just basically a sine over a cosine. Jumping across, cotangent is 1 over a tangent. Or in other words, if I imply this idea, that would be the cosine over the sine. It'd be the cosine over the sine. That's what a cotangent is. Secant, you would think that it would be the sine, but it is not. This is a 1 over cosine. And then the cosecant is 1 over the sine. And then these last three problems are problems asking you to take, in essence, this equation and solve for this unknown y. So in essence, how do I get rid of this sine? And what that is an inverse sine. You have to inverse sine, or AKA arc sine, inverse sine both sides. So if I inverse sine, that gets rid of the sine, freeing up the y. So this would be equal to inverse sine x, because I have to slap that on that side right there. So there's an inverse cosine and an inverse tangent as well. Okay. That is pretty much what you need to know for trig. If I were to focus on one thing that you need to know, that is absolutely the unit circle. You need to know the unit circle. No way around it. Please take a look at this. Whenever you do come up with trig problems and things like that, if you need to use a reference sheet, the front or back of your book, that's fine, that's cool. I totally get it. But try to wean yourself off of those things and get yourself more independent. But yeah, if you have any questions about this assignment, make sure you bring it up in the WebEx class. We will talk about it there and everything. But other than that, have a good day.